data scientist is going to need just as many social skills as computer skills. And within the computer skills, they're going to need just as many programming skills as analytics and statistics skills. And within that, I think R programming was one of my first languages regarding statistical tests. It was back at UC Davis. I still think it's a great first language. Python would be another one I recommend for a first language. My first language was C, and in some ways I don't recommend that. I do think that it's great if you want to learn lower level programming, but these days there's examples like Rust that are more forward thinking. JavaScript is something I use a lot for web development, and I think for visualization and for user experience, it's a great tool. In regards to databases, I would say a general understanding of SQL, P-SQL, and NoSQL will take you a long way. My personal favorite database is Postgres. I think it's an amazing monolith. It's just so huge. There's so many things you can do with it. But within that, plain SQL is accepted within Postgres. A starting point, if you're just starting out, learn plain SQL, start there, get used to APIs, start to understand how all the pieces work together. This is how data is stored, this is how it's shared, this is how it's secured. I'd say little pieces at a time will take you a long way. I remember when I was starting, I had a 4-page list of this is what I want to learn. And then I stopped looking at it for a year and just took little pieces bit by bit. And by the next year, I had finished 2 pages of that 4 pages. And it wasn't stressful, it wasn't overwhelming. I think sometimes when you look at a long list, you can get overwhelmed. My biggest advice is just to take it easy and step by step and try to have fun. So I'm a polyglot programmer, and I think how you get to that point is you really get to know data structures and algorithms and the core fundamentals. There's a core logic that underlies all programming languages. And the programming languages have different syntax that tailors to different uses, different niches in a way, but the core underlying fundamentals, you get the algorithms and the data structures and just really get used to them. Or if you're picking up a language, I'd say the first step is get used to the data structures, get used to the foundational algorithms, because it's kind of like when you're building a Connect set or something, like there's elbows, there's different pieces, and that's what each algorithm is. They're these really well-made pieces that haven't needed to improve in a lot of cases for many years, just because they're built that way. I do think that the foundations of that will take you further with picking up other languages. In my experience, every job is going to have different needs. And if you have to learn a new language for a new job, it won't be as hard. It might be intimidating for people, but it's pretty common. I've been working in this field for many years, and I come up to new jobs and I have to learn new skills, or someone will say, have you tried this Oracle system? And I don't work with Oracle, so being able to generalize and abstract your knowledge in order to learn new skills and tool sets is very important. Day to day is going to change generally. I do split up my days based on what I know I work best at. So I do my most deep critical work in the morning. And then around noon, I might start to have meetings. By 3 o'clock, I'll definitely have meetings. And it really depends on the day. I like to set maybe 2 to 3 days a week for heavy emails and meetings, and that's just my own personal thing. I do split it up half and half roughly, with talking to people and engaging face-to-face or virtually, as it has been the last year. And the other half just being behind a screen, looking at a terminal and talking to machines. So generally, when I work technically, I say design, build, debug, repeat. And so when I design, I sit there, I think about it, I write it down on paper. I do that that's what I was taught. It's kind of an old school way. I don't have an iPad or anything. So for me, I just write it down on paper and I decide this is how I want to lay it out. I may work through an algorithm with a pen and paper even, and then I start to build it. And in the building process, with the design, I might end up clearing and the compiler's happy or it's not happy. Either way, the debug phase is where I test all the corner cases. It's actually my favorite thing. I love debugging. Some people really don't like it, and I don't know what it is about me, but I love thinking of corner cases, and I love thinking, okay, so this might happen, and in this situation, how am I going to protect the system? Or this might happen over here. And debugging allows you to see exactly what's going on. You have to be very patient, which I'd say is one of my strengths, is patience. And I think if anyone out there is looking to be a good debugger, I think patience is your virtue. If you're calm and you're patient, the machine will tell you what it needs. You just have to listen. And so that's what the compiler and the console are for. And then you just repeat it and you keep moving forward. And I have a to-do list, and some days I don't finish the to-do list, and that's okay. And other days I might go beyond the to-do list, and it kind of balances out. Well, I'd say it was destiny. It's kind of been an unfolding path, unplanned but perfectly aligned. And it started with working with cancer genomics. I worked with a project called CG Hub, which was a supercomputer that was connecting researchers from all over the world. And that was back in 2010. So we had researchers in Germany, in Japan, the United States, Canada, and all over that were combining their efforts and sharing petabytes worth of data. So it had to be really beefy with its throughput and also with its analytical ability. So it was a pretty profound computer that we designed. And then I worked with creating the server and the API, and I worked a lot with a lot of different aspects of the grunt work, I would say. I was a lower level. But the nice thing was the two founders took me under their wings. So one was a biologist and the other guy is a computer engineer. And they were essentially combining their worlds to create a service that would help to advance medicine. It was profound to me to see how technology was unfolding, how there was so many futuristic, seeming like sci-fi things happening in medicine, and with predictive analytics and precise medicine. I think that technology has a bad reputation in regards to its social impact, because you see companies that are maybe working for greedy causes, maybe they're thinking of the upper class without taking into regard the lower class and how they can serve communities in need. I also think that you can't only think dystopian, and it's important to stay positive. I know it can be hard because sometimes there's so much going on that we need to solve. So you can go a long way with impact if you just pick one thing and stick to it. I think with climate change, predictive analytics and machine learning is going to be so key, just because when you're talking about big data and you're talking about need for real-time data, you can't have that kind of signal through the noise without these predictive methods. And you have to break through all of the misinformation. You have to break through all of the extraneous data, maybe outdated data, the ability to know when was this data published and is it still relevant. We have so much to do to make improvements. And I'd like to see a future where you could see that. You could say, I want to know what is the current state of climate change right now, and what can we do now to protect ourselves? What can we do to help? What changes can we make, and how will those changes impact the future? So like, let's say with climate change, you think about predictive analytics and how you could say these changes you make in your daily life will make this amount of change in the future. If you could show those data points, maybe people would be more impressed and maybe they would be more moved to make changes. So having metrics is more than just a business presentation. And I think if it makes such a difference in the business presentation, it would make a difference in societal presentations as well.